find the value of y that makes these vectors orthogonal, and there's y. So we want v dot w to equal 0, and if we compute v dot w, so that's what we want, and the actual value as constructed of v dot w, we have to do the sum of the products of the corresponding components to make a dot product. So 3 times negative 4 is negative 12, 8 times y is 8y, 7 times 5 is 35. Those are the products of the corresponding components. Now we have to add them up, and we want that to equal 0. So that'll give us a pretty simple equation. 8y plus 23 is equal to 0. And so y should equal negative 23 over 8. So if we choose y to be that particular value, then these two vectors will be perpendicular to each other. Orthogonal is a term that is more general than perpendicular, but in this case, it just means perpendicular. Second problem, let's find two vectors that are not multiples of each other, because once we find one, then we can multiply it by 2 and it will still have the property that it is orthogonal to the given vector 1, 1, 1. So let's say we have a vector ABC and we want it to be orthogonal to 1, 1, 1. Then that means that we want this dot product to be 0. The dot product is ABC, A plus B plus C. So let's just try, for example, making A equal to 0. So in other words, we'll take the vector 0, BC and see if we can work with that, just to simplify things a little bit. So that would be just B plus C equals 0, so C would be the negative of B. So we could take the vector, for example, we could say that we'll call it V, could be the vector 0, 1, negative 1. Then this vector is orthogonal to 1, 1, 1. The dot product would be 0. And now I think having done that, we could probably just guess at some other vectors that are not multiples of this one, that are going to be perpendicular or orthogonal to this one, just by picking a different variable to be 0. If we had B equal to 0, then we would have had A plus C here. So that would give us 1, 0, negative 1. And then yet another one, if we pick the C to be 0, then we could try 1, negative 1, 0. So there's 3 vectors, none of which are multiples of each other, that are perpendicular to 1, 1, 1.